Today, limits made easy. One of my students suggested this problem, and with good reason. For many students, when they do a limit problem and they see these three words from the definition, I can almost predict the reaction. Surprise, then anger, then possibly tears, and finally just a general sadness. But in 10 minutes or so, I can make it easy for you. To understand proving from the definition, I want to start first with what I call proof by internet. Suppose you put up on your website the following as an invitation to everybody in the world. Tell me how close you want fx equals 3x divided by x plus 5 to be to 3, and I'll tell you what x has to be greater than. And I agree with you that if you can do that for the next 30 days, then I'll accept that the limit of fx as x goes to infinity is in fact 3. So the first reply you get is from someone saying that you shouldn't end a sentence with the word than, so you have a bit of a laugh and then you block them. The second person comes through and they say that they want you to get to, how close? Close, they want you to be to within a half of 3, a half a unit. So you go off and draw a graph, and the graph looks like this, and you can see here the function that you've drawn in red. You've also drawn the limit of 3 in green, and you've drawn another line horizontally at 2.5. And you can see that the function is closer than a half to 3 once you get above about 25. So you just pick a number well above that, say 30. We've drawn the vertical line there in blue at 30. And so then you get a scrap of paper and you say if x is greater than 30, and then you go dot dot dot. I won't put all the numbers here that you've done, and the final line will say that fx minus 3, or the absolute value of that, because you want the distance from fx to 3 to be less than a half, so that'll be the last line. And you come and show me that, and I say, yeah, that's fine. And then the next day someone comes through and asks you to get to within 1/1000th of a unit. And so you go off and do the same thing. After about a week, you come back to me and you say this: look, I can prove to you that no matter what closeness anybody suggests to me on the internet, I can always work out a number so that if x is greater than that number, then the function will always be as close as it needs to be to 3. And that's exactly what we do in proving the limit from the definition. So now let's do a proper proof from the definition. Okay, here's the question in the top left-hand corner. And now I'll put up the definition of a limit, and hopefully you'll see the link to what we just had with the proof by internet. So the limit as x goes to infinity of fx equals L if for every epsilon greater than 0 there exists an m such that the absolute value of fx minus L is less than epsilon whenever x is greater than m. So now let's do the proof. I like to set out by putting let epsilon be greater than 0. I then write the absolute value of fx minus 3, and it's tempting at this point to immediately put less than or equal to epsilon, but you need to resist that. We're going to put as much work into this before we mention epsilon. So I now say that that equals the absolute value of 3x on x plus 5 minus 3, just filling in what fx is. Simplify that, I get that it equals the absolute value of negative 15 on x plus 5. Now x is greater than 0 for everything we're talking about here, and so we can state that that is less than or equal to 15 on x plus 5, which is less than or equal to 15 on x. And that's about as far as we go. That last step there just helps in terms of making the mathematics a little bit easier from now on. Nice to get just a single x down the bottom of the expression. So at this point now we need to get the epsilon in, so we write as follows. So if 15 divided by x is less than epsilon, then the absolute value of fx minus 3 will be less than epsilon. So you can see we've made some progress because we've worked out really the circumstances under which the absolute value of fx minus 3 will be less than epsilon, which is what we want. So I'm running out of room. I'm going to push that last line up to the top, and now we can continue. We say the following. Now 15 on x is less than epsilon implies that x is greater than 15 on epsilon. So let m equal 15 on epsilon. Then the absolute value of fx minus 3 will be less than epsilon whenever x is greater than m. And that's the end of the question. Hopefully you'll get full marks. And that's it for Limits Made Easy. I hope you found it useful.